Hello students, welcome to this session. I have just solved the NEET test 72. It is about 2 a.m. and today I was feeling tired, so I slept at 9 a.m. and wake up around 1. So the paper is now 2, so it will be uploaded by 2:30 I suppose, because it will take half an hour more for me to extract and upload. Now the paper is quite easy one. We can regard two questions as tough only. In question number 2, I think the solution and the options both are horribly wrong. In 38, they have done some mistake of that putting ohm to as kilo ohm, therefore the answer is not coming. Otherwise, the paper is quite simple. It's not a tough paper, it's a paper you can definitely crack. So if I take out these two questions and take it as out of 170, so for an average student, again the 135 plus out of 170 here should be the score, and for the good one it should be 155 plus out of this 170 in this particular test. So let's begin this test. The number of revolutions done by electron in 1 second in the first orbit of a hydrogen atom. So in the first orbit of an hydrogen atom, we know this number of revolutions is basically frequency, which is v upon 2 pi r. V is 2.18 into 10 to the power 6 meter per second, and radius is 52.9 picometers. So if you do this, what you have, this picometer is 10 to the power minus 12, so that comes out as 10 to the power 18 into 2.18. 2 pi is, let's say, 6.28 into 52.9. that is what you are roughly getting. So if I do this, this is roughly 1 by 3 into 50, that is 1 by 150, so that is, it would be 6 point something, and in 10 to the power minus 3 and 10 to the power 18, so it would be 6.57 into 10 to the power 15. So this is going to be the option number A here. Next, given a sample of radium-226 having a half-life of 4 days, find the probability a nucleus disintegrates after 2 half-lives. Okay, probability that disintegrates after 2 half-lives means it should survive till 2 half-lives. So it should survive till 2 half-lives. So it should survive till 2 half-lives. That means the probability that it disintegrates after 2 half-life would be equals to 1 by 4. So as per me, this answer should be equals to, what I can say, it should survive the 2 half-lives. That means the probability of that is 1 by 4, but I don't see any option, so it's tough to comment now. So probability a nucleus disintegrates after 2 half-life for me is 1 by 4. I'm not doing anything, and if I see their solution, they have taken the disintegration of each nuclei is independent of the any factor. Each nuclei has same chance of disintegration. I don't agree. Go again. A ball of mass m moving at speed v makes a head-on collision with an identical ball at rest. The kinetic energy of the ball after collision is 3/4 of the original. What is the coefficient of restitution? Okay, makes a head-on collision with an identical ball at rest, and kinetic energy after collision is 3/4 of the original. That means the loss is 1 by 4. We generally write the losses half m1 m2 upon m1 plus m2 into u relative square, that is initial speed of approach, into 1 minus e square. That is the general result that we get from Newton's law of restitution. So here the loss is 1/4 of the total. 1/4 of total, only one has half mu square. So here what will have m1 upon, because both are identical, this reduced mass becomes m by 2. U relative would be u because one is at rest, into 1 minus e square. So now what you get, half mu square goes, so you have, if you do this, 1 by 2 comes out as 1 by minus e square, so e square is half, so e is 1 by root 2. So the coefficient of restitution as per the question is equals to 1 by root 2 if we take the details. Next, spaceship traveling in the interstellar medium is picking up dust at a rate dm by dt is alpha v, where alpha is a positive constant. V is the instantaneous velocity, m is the total mass at any instant, the instantaneous acceleration. So because here we directly write the thrust force is what we have, minus v dm by dt, or v relative dm by dt what we have, so its relative velocity would be minus v with respect to that dv by dt is alpha v, and that is equal to ma, so m times a, so a comes out as minus alpha v square by m. So as per this, the option B is the appropriate one. Next one, you have a ball of mass half a kg attached at the end of a string having a length half meter. The ball is rotated in a horizontal circular path about the vertical axis. Maximum tension that it can be arrested with 324, the maximum possible value of the angular velocity. I've done this same question yesterday, I think in the JEE main maybe. So here what happened, let's say it goes like this. So let it be T, let it be mg, draw the FBD. Let's say this is theta, this will be theta, this is radius. So if I do the centripetal force expression, it says T sine theta is m omega square L, and L I can write from the geometry here. This sine theta is R by L. So what is not R, sorry, not L, it is R, sorry, it is m omega square R. So now what is R? I can write as L sine theta. So this theta terms is gone. So directly I can say omega max would be T max upon omega L under root. This is the result on ml, sorry, not omega L, it is ml. So what is T max? It is 324, m is half, and this is also half. Now 324 is the square of 18, and this 2 also comes, so this is 36 radian per second is the omega max. So go for option D. Now a car is moving on a circular level road of the radius of curvature 300 meter. Okay, if the friction coefficient is 0.3 and acceleration is 10, the maximum speed the car can have is. So because it is a level road, so Fs should provide mv square by r, and that should be equal to less than equal to mu sn, which is mu smg here, because there is no slope or something. So the maximum speed Vmax, you know, is equal to under root of mu s rg. So what is mu s? Mu s is 0.3, r is 300, g is. So this is easily solvable. Less than equals to root of 900, that is 30. This is in meter per second. If you convert it into kilometer per hour, you know that is 108 kilometer per hour, because 10 meter per second is equivalent to 36 kilometer per hour. That analogy you use from class 9th. Next one. If E denotes electric field in a uniform conductor, I is the current, Vd is the drift velocity, P denotes the thermal power generator. Which of the following graph is correct? Okay. Now you remember this power expression is V square by R. And you know resistance is fixed, so power would be, what we can say, is proportional to V square. And V you typically write as uniform. If I take it area, it would be E by L. So this P is definitely going to be proportional to E square. First thing that I can make it out. So P versus E graph would be a parabolic one. So this B option seems to be the appropriate one for us. So definitely we'll go for option B. That is what I can directly make it out. Next one. The resistance of a wire is R ohms. The wire is stretched to double its length, keeping volume constant. So because volume is constant, length is double, you all remember resistance would be proportional to L square, so it will become 4 times R. So this question has also been asked many times in different forms, even in NTA. Next. A motor which is loaded as an effective resistance of 30 ohm and inductive reactance of 40. If the motor is powered by a Vmax of 420 volts, the maximum current is. So what we'll have, we will have Z also. Z would be R square plus XL square, that is 30 square plus 40 square, that is 50 ohms. So directly you can say Imax is Vmax by Z, so that's not a tough one. So Vmax is 420 and this is 50, so 42 by 5, that comes out as 8.4 amperes. So that's an easy one from AC. Next one. A uniform but time varying magnetic field exists in the circular region of radius A directed into the plane. The magnitude of the induced field at point P outside the region at a distance R. So just remember, outside the region of this circular, or you can, what generally we write the cylindrical one, that E you remember is R square by 2R into dB by dt. That is for outside. And for inside it was proportional to R, so it is what we write, R square by 2R dB by dt. This is for R greater than equals to R, and inside point also I am telling you that is equals to R by 2 dB by dt. The magnitude basically you can talk about. So here it would be inverse to R, so it will decrease as 1 by R outside. In the inside region it would have been increased as R. Next. Electric dipole is placed at an angle of 30 degree with an field this. It experiences this torque, the charge, if the dipole length is. Okay. So first of all, the torque should be equals to P sine theta. So what we have, 4 is equal to P is 2 into 10. Oh, P we need to find out. Okay, so let me call it P. P I can write as QD. So Q into D. D is 2 into 10 to the power minus 2. E is 2 into 10 to the power 5, and this is 30 sine 30 is 1 by 2. So this goes. So this is 2 into 10 to the power 3 times Q is 4. So Q comes out as half into, sorry, not half, sorry, 2 into 10 to the power minus 3. So it is 2 into 10 to the power minus 3 coulombs, minus 3, not C, okay, minus 3. So it is 2 millicoulomb as per me, so it should be B option. Next one. We have two uniformly long charged wires with linear densities lambda and 3 lambda, okay, placed along x and y axis respectively. Determine the slope of electric field at any point on the line y equals to root 3x. Okay, so you have along x1 is lambda, along y1 is 3 lambda. So take any point y equal to root 3x like this. So let's say the coordinates would be h comma root 3h, I can write. So here, due to this x-axis wire, the field would be along y-axis, let's call it E1. Due to this would be along x-axis, let's call it E2. So the value of E1 would be 2k lambda upon distance from it would be equal to root 3h. From E2 would be 2k lambda, lambda is what you have, 3 lambda upon r is h. So what we have, if the net electric field, whatever be it at the angle with the horizontal, it would be tan theta would be equals to E1 by E2, I know. So E1 by E2 will come out as, this would be 2 by root 3 and this would be 6. So it is 1 upon 3 root 3. So I'll go for the option, whatever option I'm getting. C is the exact option I'm getting. Next one. The time period of a satellite of Earth is 5. This question is again coming again and again. Now separation is increased 4 times. I have remembered this answer now. So we know t square proportional to r cube, t proportional to r की power 3 by 2. So it is increased 4 times. That means 4 to the power 3 by 2. That it means it becomes 8 times. So 8 5s are 40 hours. Next one. So but I don't know how many times this has come. The radius of the Earth is r. The height of a point vertically above the Earth's surface at which acceleration becomes 1% of its value at the surface. So it becomes 1% of the value of surface, that is 1 upon 100 into gm by r square. And that would be equal to, because it is going to be a large distance, let's say it is r plus h whole square. So this goes. So r plus h whole square equals to 100 r square. So r plus h, take the root, comes out as 10r. So h directly you can write it as 9r. Because it is height is asked, it is 9r. If the distance from center would have been asked, it would have been 10r. So both are easy questions from gravitation. Next. If the temperature of the sun was to increase from T to 2T and radius from R to 2R, the ratio of radiant energy received on Earth. So the fraction of energy remains same. So the energy radiated by sun will change, and that h of sun that we say is proportional to a t की power 4, because area is proportional to r square. Now r is doubled, so this will become 4 factor. T is doubled, so this is 2 to the power 4. So 16 4s are 64 times more energy it radiates. So that fraction remains the same. So Earth also gets 64 of the initial one that it is receiving now. Next one. A Carnot engine works between 300 and 400 Kelvin, has 800 joule of useful work. The amount of heat energy supplied is. So what we can write, we know efficiency, this 1 minus Tc by Th, and the general definition of efficiencies is W upon QH. So what we have, 1 minus 300 by 400 is equals to 800 by QH. So this is 1 by 4 is 800 by QH. So QH directly comes out as 800 into 4, 3200 joule. So 3200 joule it receives, 2400 it will radiate out, and 800 is the useful work. Next one. In the given figure, the area of the frictionless and movable piston is 1 meter square and is being held in equilibrium by an external force. Now the external force is slowly removed due to, so that the piston displaces by L by 2, where L is 1. The natural length of the ideal springs is 1 meter. Okay, spring constant is given as 100 Newton meter per meter. The pressure of the gas in the final situation will be, okay. So it is frictionless, movable piston held in equilibrium, external forces slowly removed, okay, and that displaces by L by 2. Definitely it will come now here. Spring constant is this, the pressure of the gas in the final situation will be. So in the final situation, what you will have, if I take this piston, the first spring, this one, the gas one spring is extended, so it will exert a force KL by 2 here, and this is compressed, so this will also exert a force KL by 2, and this should be balanced by that P into A, because that is how the thing will be. So simple force balancing I am doing. So P into A would be KL by 2 plus KL by 2 is KL. So the pressure would be KL by A. What is K? 100, L is 1, A is 1, so it is 100 Newton per meter square. I'll go for B. So question is good in language, not tough to solve. Next. Galvanometer with a scale divided into 100 equal divisions has a current sensitivity of 10 divisions per milliampere. That means for 100 the total current it can allow is 10 milliampere, that is Ig. And voltage sensitivity 2 divisions, that is 250, 100 by 2, that is 50 millivolt. So from this data I can make out G, that is a galvanometer resistance would be Vg by Ig, and that is 5 ohm. Now this is asked only, so the resistance is 5 ohms. I thought it would be some conversion one, so it's only the resistance of the galvanometers need to be calculated. Now, electron experiences no deflection, is subjected to electric and magnetic field is this: when both the fields are normal to the path of electron and to each other, the electric field is removed, then the electron will revolve in an orbit radius. Okay, so what we say, for zero force we had condition that the speed should be equals to E by V. Okay, so now if the electric field is removed, the force of magnetic field would be QVB, that should be equal to mv square by r. So r would be equals to mv by qb. So if I write this v as E by v, what I have, m E upon q b square. So m is given, E is given, what is E? E is 3.2 into 10 to the power 5, q you all know, and b square, that would be 4 in 10 to the power minus 6. Okay, so now what you have, this is 31 and 19, that is 10 to the power minus 12. This will become 10 to the power 6 and 5 11, so it is 10 to the power minus 1 now, into 9.1, and let's say this would be 2 by 4, so this is 2. So what it comes, it is 4.5 into 10 to the power minus 1 meter, that is 0.45 meter. Not that tough calculation, you can make it out. Next, calculate the real angle of dip. I have taught this thing in many previous tests to you. If a magnet is suspended at an angle 30 degree to the magnetic meridian, the dip needle makes an angle of 45 degree with the horizontal. So here I already told you, let me tell you once again. Let's say this is the magnetic meridian, actual plane in which Earth's field rise. So it would be the Earth's field B, this would be the corresponding BH, and this would be BV. And what this dip angle, let's say theta naught, real dip. So that real dip you know is equal to BV by BH. Now if you have taken a plane at 30 degree to this, at this angle 30 degree to this, so the B vertical remains same, but the BH will change. This will become BH dash, and new angle with it, the apparent dip theta apparent I can write. So tan theta apparent would be BV upon BH dash, and BH dash, if you remember, would be equal to BH cos 30 here, so that would be tan theta naught into cos 30. This is tan of theta apparent. So what we have, makes an angle 45, that is theta apparent, that is 1. Tan theta naught I am searching, and cos 30 you all know is root 3 by 2. So what I get, tan theta naught is equal to root 3 by 2, so that theta naught is equal to tan inverse of root 3 by 2. So going by this, I'll go for option A. So just remember, this is specific concept, and as I told you before, if you want to study it more, do it from H.C. Verma book. It is given very nicely in it. That next, the x and y coordinates of a particle at any time is this and this. The acceleration at 5 seconds, I can make it out. Ay is going to be 0 because it's a linear function, and for ax double differentiated, so vx would be 7 plus 8t, and ax would be equals to 8, that is constant. So acceleration at all instant would be 8 meter per second square here. Next, a large number of bullets are fired in all direction with the same speed v. What is the maximum area in the ground that they cover? You remember this thing, the maximum range for anyone, you know, it is going to be R max, and if you throw in all directions, it will go like this in all directions, it will be a circle. So maximum area would be pi R max square, and R max you know is equal to u square by g at 45 degree whole square. So it is pi u to the power 4 by g square. That is option B. Very common question. Next one, your body of 50 kg suspended using a spring balance inside a lifted rest. If the lift starts falling freely, the reading of spring balance is, always remember, whenever there's a free fall, every bond is broken, every normal tension always becomes 0. Because here if you do this is, let's say, your spring balance, and because the lift is in free fall, so in the free, let's say it is suspended like this, or they take the flow to be like this. Okay, let me draw it. Let's say this is the lift. So because the lift is going with acceleration g downwards, let's say in frame of lift, if you work, you have to apply a pseudo force mg upwards. This is mg, this is balanced, so that spring force requirement is 0, so reading would be 0. Next one, the normal reaction in a body placed in a lift moving up with constant acceleration 2 meter per second square is, okay, so because it is going up, as I told you here, if you see from the lift, the pseudo force would be what we can say, the pseudo force will change. So let me place it like this. So because it is going with acceleration a upwards, so if I see in the frame of lift, it is stationary, and this would be mg plus ma, and this would be normal, so normal will become mg plus a. So what we have, 120 is equals to m into 12, so m comes out as 10 kg for you. So mass of the object would be 10 kg as per this thing. Okay, so option A is the answer. Go ahead. Next one, 1 milligram of matter converted into energy will be, so we know Einstein's relation equivalence. 1 milli means 10 to the power minus 3 grams, that is 10 to the power minus 6 kg. C square is 9 into 10 to the power 16, so this is 9 into 10 to the power 10 joules. So just remember what is 1 milligram. Next, in a radioactive disintegration, the ratio of the initial number of atoms to the number of atoms present at any instant of time equals to its mean life is, okay, so ratio of the initial atoms to the number of atoms present, that we write as n upon n naught, that you write as e to the power minus lambda t. So that ratio at t equals to mean life, that is t equals to tau, that is 1 by lambda, is e to the power minus lambda, t is 1 by lambda, so e to the power minus 1, that is 1 by e. You can write, this is what I have written, n by n naught. Okay, so I am wrong here because the question is asking for initial to the number of atoms present, it is asking for the reverse ratio, so that would be e. So be careful, otherwise you can do mistake like me. Next one, there is a particle of mass 3 kg attached to a spring with force constant. This execute SHM. The time period is, so it says standard 1 2 pi root m by k. Nothing you have to do much. M by k 3 by 48. 48 is what we have. 1 by 16. 1 by 16 is 1 by 4. So it comes out as pi by 2. So the option is B. That's an easy one for you. Next one. A point performs SHM of period t, and equation is this. After the elapse of what fraction of the time period the velocity of the point will be equal to half of its maximum velocity. Okay, so first of all, when the velocity is half of its maximum one, you have to remember, so just differentiate as first. So V is dx by dt, that comes out as omega a cos of omega t plus pi by 6. So the velocity of point will be equal to half. Half means the half of the maximum means omega a by 2 is omega a cos of omega t plus pi by 6. So it directly comes out as cos of omega t plus pi by 6 is half, and you know cos theta is half first when pi by 3. So pi by 3 means omega t plus pi by 6 is pi by 3. So omega t is equal to pi by 6. So t is equal to pi by 6 omega, and omega you know is 2 pi by t. So that is t by 12. So what time is needed? T by 12 time is needed for this particular thing to happen. Next one. Next, Huygens wave theory of light couldn't explain photoelectric effect. You know that it led to the discovery of that dual nature, because interference, polarization, diffraction, all three things you study in the chapter called wave optics. So that is wave optics, that is explainable by Huygens theory, but this photoelectric effect and Compton effect can't be explained. Next, at the closest approach, the distance between the Mars and Earth is this. When the planets are at this closest distance, the time it would take to send a radio message from a space probe of the Mars to the Earth is. So because it is in vacuum, the speed would be 3 into 10 to the power 8. So time would be 660 million kilometers. So kilometers and million you know is a 10 to the power 6. 1 million what you have, that is 10 lakhs. So if you write that 10 lakh, it's like this. So you have 6 zeros. Okay, you remember that famous video of Sambit Patra and Gaurav Vallabh regarding that billion thing? Okay, trillion dollar thing. Okay, now this one, this is the speed is 3 into 10 to the power 8. So what do you have? This 20 into 10. So that is 200 seconds that we will get here. So you can see the speed of light is very fast and radio waves travels with that speed. Next, block of wood floats in fresh water with 2/3 of the volume submerged. In oil, the block floats with 1/4 of the volume submerged. So what we have here, in the water, 2/3 of the volume, that is 2/3 V into rho of water into G is equal to its mg, and in the other one it is 1/4 V into density of oil into G is equal to mg. So comparing this, what we can see, 2/3 rho of water is 1/4 rho of oil. So the rho of oil comes out as 8/3 of water. So 8/3 into 1000. So 8000 by 3, 8000 by 3 you will be 2666.7 kg per meter cube. Next, go. Ideal fluid flows through a pipe of uniform, not uniform body. This cross section is varying. Okay. The ratio of velocities is, because diameter is 1:2, so area, if this is A, this will become 4A naught. So area is becoming 1/4, so speed will become 1/4 because AV is constant. So VA would be 4 times of VB, because area of B is 4 times of area of A. So that ratio of velocities would be 4:1. You can directly make it out, not a tough one. Next, you have an astronomical telescope with an angular magnification of 5 magnitude. Separation between objective and eyepiece is this. The final image is at infinity. Okay. The focal length and the objective length is, so it is the normal adjustment that is talking about. So we know magnification would be FO by FE, that is 5, and you know that tube length is FO plus FE equals to 36. So going from here you need to calculate. So FO is 5 FE, so 6 FE is 36. So FE is 6 and FO comes out as 30. So what we have, FO and FE would be 30 and 6 as per this. So go for option D, easy one for you. Next, compound microscope having magnifying power 35 with its eyepiece of focal length 10. Assume initial images at least distance, that is the near point adjustment, the magnification is. Okay. So here we know that magnification, we typically write it as MO into ME thing. And this ME, because it is in the least distance, this V, you all remember, it is equals to 1 plus D by FE. Okay, so M of O would be M upon 1 plus D by FE. So total magnifying power is 35. D you know is 25. This FE is 10. So 35 upon 3.5. So it is 10. Now because option are 10 and minus 10, you just remember the objective lens produces an inverted image, so magnification has to be negative. So I'll go for minus 10. That would be the more appropriate one as compared to plus 10. There I have just calculated the magnitude, and because both signs are given, I'll go for -1. Next, when a ceiling fan is switched off, the angular velocity falls to half and it makes 36 rotations. How many rotations will it make before coming to rest? So it's a standard question. You can apply that third equation 2 times, or I'll typically explain it like this. Draw this omega versus t. Let's say initial velocity be omega naught, because it will have a constant retardation. I assume it goes like this. So by the time the velocity becomes half, so common sense says if this time is t naught, this would be t naught by 2. So this is the number of rotations would be, the angle covered would be given by this delta theta 1 that I can raise 36 rotations, or 36 into 2 pi, that is equal to the area of this trapezium. That would be what I can write, omega naught plus omega naught by 2 into t naught by 2, or you can write it as 3 omega naught t naught by 8. Now how many more rotations will it make before coming to rest? So here this area will come out now. And what is this area? If I do again, this is simple triangle. So half into omega naught by 2 into t naught by 2, because this gap is still t naught by 2. So it is omega naught t naught by 8. So definitely it is going to be 1/3 of this, the 36 rotation. So here you can say 1/3 would be 12 rotations. You can go for option D here, or you can do by the third equation also. Next, if a body lies in the YZ plane, then according to the theorem of the perpendicular axis, so because the body is in YZ, the plane perpendicular to this plane, the axis perpendicular to this plane would be IX, so IX would be equal to IY plus IZ. So it's simply testing you know or not what do you mean by that perpendicular axis theorem. With forward bias mode, the PN junction mode is in which the width of depletion region increases, no. Potential barrier increases, no. Acts as a closed switch, yes. It behaves as a simple wire, so it acts as a closed switch, not as an open switch. Next one, transistor used as an amplifier in common base mode with a load of 5, current gain is this, input is this, the voltage gain is. So you can directly say this is alpha, the current gain. Generally we write here R output upon R input, current gain into voltage gain. So current gain is 0.98, the voltage, the resistance gain, sorry, what we write is 5 upon 70. So it is basically not gaining, it is, I doubt this data, how they have given, this cannot be kilo ohms, because in this case I don't see any gain. So if I go by the data they have given, this is 4.9 upon 70, that is what I'm going. So none of such options I could go for. But if I take it as 70 ohms, then it will be 5 kilo ohms, so it becomes 5 into 10 to the power 3, and this is 70. There I didn't write because both were kilo ohms. So in that particular case it becomes 4900 by 70, so this comes out as 70. So it would be 70 if this is 70 ohms, not 70 kilo ohms. So printing mistake is there. Next, the total kinetic energy of a mixture of a 4 gram of hydrogen and 4 gram of helium is. So what we can say, for an ideal gas, total energy is basically your total internal energy is total kinetic energy only. So energy would be 4 gram of H2, means this is 2 moles and this is 1 mole. So this is 2, this is diatomic, so 5R by 2 into 300, that would be 1 into what we have, helium, that is mono, into 300. So this is 1500 R, and this comes out as 150 into 3, 450 R. So it is 1950 R. I'll go for option C here. Next one, the SI unit of specific heat capacity, you write it as joule per kg per Kelvin. You all remember, so this is joule per kg per Kelvin. This is specific heat, molar specific heat at joule per mole per Kelvin. Next, in YDAC the fringe width is this. If it is immersed in water of refractive index 4 by 3 without disturbing arrangement, the new fringe width is. So fringe width is lambda d by d, you remember. So in dipping in water, lambda will become lambda by n of water, lambda in water. So this fringe width will also become what we can say divide by water, so it will become 3/4 of what it is, because it is inverse. So 3/4 means 0.3 mm I can go for. Next, in a YDAC the distance between slit is increased 10 times, whereas the distance is halved in the fringe width. Again the same formula we have to use. This is 10, this is half, so it becomes 1 by 20. So it's both question on the same concept. Next, if the end correction of an open pipe is 0.8, then the inner radius of that pipe will be. Open pipe has end correction as both sides, so it is basically 2e in our terms, that is 2 times 0.6 r, that is 0.8 centimeter. So the radius would be 0.8 upon 1.2. just remember it's not open one, so it is what we can have 2 by 3 centimeters. So just remember, otherwise you will go for you will have the answer double of that. Okay, so just remember this thing. Next, a transverse wave pulse is generated at the free end of a string which is hanging from a rigid support. The speed of the wave pulse at distance x from the free end is proportional to. Okay, so here what it assumes, it will assume it has some mass, and because it has some mass, tension will be varying. So let's say at distance x from the free end, first of all what would be the tension? So we say the tension supports this x length, so that would be equal to whatever be the mass density, let's say mu into x into g, that is what the tension will be. And we know velocity is root t by mu, so t is mu xg upon mu, so it is proportional to root x. You can make it out. So as it goes up, tension increases, the speed increases, and it would be root x like that. Particle moves in a velocity with a velocity this under the influence of a constant force. The instantaneous power is, that means there should be some force which retards this. By the instantaneous power applied to the particle by this force is F dot V, I can say. So in that instant the power due to this would be F dot V, no need to do anything else. So F dot V, this is 10 into 550, minus become plus 30 plus 26 are 120. So this is 50, 30, 80 plus 120, it is 200 watt. So go for option C. So this was today's paper. Thanks for watching. Keep liking, keep sharing the channel, share it to maximum aspirants you can.